Hello everybody, thank you for joining me on this quick video. I'm going to do a very brief introduction of my invention, the Eclipse valve, and show how it compares to existing valve designs that are commonly used in flow control. The first one we're going to look at is a globe valve. Now this is the global standard for being able to precisely control flow. It does a very good job of that, but it does have inherent design flaws. One of the problems with the globe valve is it has a very turbulent flow path. Now you know this causes cavitation, bubbling, vibration, noise, which can damage everything downstream of the valve and the valve itself. You also have very expensive costs to actuate this. You need a very heavy linear or multi-turn actuator to be able to control the flow and automate your system. And then the other problem here, and that's the biggest one, is that there's a very large pressure drop. So you have a full bore valve that can flow as much as a globe valve that's 4 times the size. There you have the problem. So if we take a look at a full bore valve like a ball valve, it's not very good at flow control, but it is very good at shutting on and off. However, it does also have that very similar turbulent flow path. You require a lot of torque to be able to actuate this, and this is due to there having be a large surface area between the ball itself and the seals in the interior body of the valve. You also have poor flow control characteristics. Now there are characterized ball valves that do a pretty good job of being able to precisely control flow. However, they're very expensive and they're not cheap to manufacture either. And then you also have flow directed to the sides of the valve itself and interior walls and piping. So when you see that turbulent flow path cause bubbling, cavitation, noise, vibration, it actually causes damage inside the valve and to piping and everything downstream of the valve. So let's talk about my valve, the Eclipse valve, and how it works. If we're looking at the mechanism from the top, this actually has 2 sliding plates and a pinion gear. You see that it is quarter turn like a ball valve, but it requires very little torque, so you can use a very small actuator with it. Now, if I'm looking at the orange part being where the flow goes through the valve from the top, you can see that these plates will cut off flow and control it anywhere in between. The reason why I'm using 2 plates, not one like a gate valve, is because I want to direct that flow towards the center of the pipe and away from the piping walls, again, cutting down on vibration, noise, cavitation, and damage downstream of the valve. Now, I have also incorporated an incline on those gear racks. It's very imperceptible if you're looking at this image, but it has about a ½ a degree of incline. And what that does is, as the valve closes, it's pushing those plates to the interior walls of the body of the valve. So you're creating a more positive shutoff, metal on metal, pushed together to be able to shut off more positively. If I'm looking at it from the front, this is how the 2 plates slide. You can see it works very similarly to a cigar cutter. In fact, that was the inspiration for it. I just wanted to adapt that kind of simple mechanism to a 90-degree actuation. And if we're looking at it with the body of the valve on there, you can see again how we're directing the flow towards the center of the path. The end result is that we have a very equal percentage type of flow, and it's very easy and precise to control your flow just like a globe valve, but it's full bore like a ball valve. It's also quarter turn like a ball valve. It is also inline serviceable, so it's got 6 bolts that can be rebuilt in just a simple matter of a minute. 3 moving parts, very simple, inexpensive to manufacture, and should be able to replace any kind of flow control device out there, as it is superior to all of those designs. If you have any questions, please reach out to me. My contact information is on the screen. Again, thank you very much for watching this brief video.